we're going to spend a little time with Andrew Digby. So Andrew has such a cool job. New Zealand's amazing because, you know, with it being an island, so many bird species evolved to fill all of these niches that normally would have been filled by other animals like mammals. And so he's a conservation biologist, and he's the scientific advisor for the Kākāpō Recovery, which is an amazing program trying to save a wild ground species of parrot in New Zealand. So I'm going to bring Andrew in with us now, and we'll let him take over for a bit. Hey, Andrew, how are you?
I'm good, Joe. How are you?
I'm good. So great to have you joining us today from New Zealand. I'm in Canada. You're in New Zealand. I don't think it's harder to get more further apart, but we're excited to have you through the magic of technology. And it looks like, well, it's a little hard to tell. Is it sunny out there or a little bit of cloud action?
It's a bit of everything today. Bit of rain, bit of sun, bit of wind. Yeah, the full works.
All right, fair enough. Well, Andrew, I'm going to let you take over. I can't wait to dive into your world for a little bit.
Cool. Okay, I'm just going to share my screen. Okay, hopefully you can all see that screen. Give me a shout, please, Joe, if you can. So, yeah, kia ora koutou, everyone. That's hello, everyone. Ko Andrew Digby aho, ko te kai tohu pūteo o Kākāpō me tākehei o te papahatawhai e mahi ana. So I am the scientist for the Kākāpō and the Tākehei conservation programs here in New Zealand with the Department of Conservation. And yeah, I'm really excited to be talking here today. And I'm not quite sure how I follow that from Shafkat. Snow leopards are amazing. They're one of my favorite animals, and it's such a cool talk. So yeah, that's really exciting to see some of the work that's going on around the world. But I thought before I talk today, I'll just briefly talk about who I am. Yeah, just because you may wonder why this guy with a slightly weird accent is talking to you about these birds. I grew up in the UK. I had two passions as a kid. One of them was definitely wildlife and nature. My brothers probably didn't share that passion quite as much. They got a bit bored when we spent a lot of time at nature reserves. But yeah, I was definitely the nature nerd. And I really loved that passion, but I ended up following another passion for a job initially. I was really keen on astronomy, so I ended up doing a PhD in astrophysics, ended up with NASA doing a postdoc in New York, and helped to build an instrument in Hawaii on a telescope to try and look for planets around other stars. So I kind of come from a slightly unusual background for conservation. But when I moved to New Zealand in about 15 years ago, I ended up going back to that and decided to make it my career. So retrained as a PhD in conservation biology and worked with kiwi for a few years. And today I work with these two really unusual birds, both large flightless birds only found in New Zealand, the takahei on the left and the kakapo on the right. And I do that as obviously as part of a team. There are about 20 of us in our team. We have a team of field rangers who do all the hard mahi, all the hard work on the ground. But we work with lots of other people. We work with people who are specialists in technology, for example. We work with lots of vets. We work with lots of scientific experts from within New Zealand and around the world. And we have a very close relationship as well with Ngāi Tahu, one of the local iwi or Maori tribes. And we work really closely with them in terms of the work on the ground, but also setting the direction for Kākāpō conservation. And that's a key part of what we do. So today I kind of want to talk to you in three parts. And I think what we're talking about fits in quite well with the theme of the festival, the weird and the wonderful. Well, you don't get much more weird than wonderful than Kākāpō, one of the most unusual birds in the world. And I'll introduce those to you. Also, some of the challenges that we face as well. So Kākāpō conservation is not easy, as like a lot of conservation of other threatened species. And I'll talk to you about some of the management methods that we use, but also the good news as well. So some of the issues that we face, but some of the ways that we've been able to solve them. And this very much is a positive story actually with Kākāpō conservation and how things have been turned around. So what is a Kākāpō? And many of you may not have ever heard of Kākāpō before. And I guess they're a bird which doesn't really think it's a bird. They're a parrot, but they're the heaviest parrot in the world. They're the only flightless parrot in the world. They're nocturnal. They're the only lek breeding parrot. They have this weird breeding system. They have the slowest metabolism of any bird. Basically, everything they do is kind of different from every other bird. They really, really do not follow the rules. And they've been on their own evolutionary path for about the last 30 million years. So yeah, they're definitely one of the real oddities of the bird world. And they're only found in New Zealand. And they used to be really, really common in New Zealand before people arrived. They used to be found throughout both the North and the South Islands of New Zealand. And even when early European settlers arrived in the 1800s, towards the late 1800s, they were still so many of them around that they would complain that they couldn't sleep at night in their bush camps because they were making too much noise. And even every bush camp would often have a pet kakapo. They described shaking them from trees like apples or finding 100 of them in a mile. So they're extremely common. But those settlers brought with them some mammals, and New Zealand never had mammals before apart from bats. So things like cats and ferrets and stoats had a devastating impact on New Zealand's native wildlife, and including the kakapo. So by the time it got to the 1970s, no kakapo populations were known. In fact, many people thought they might be extinct. And so there was some last-ditch searches to try and find them in Fiordland down the south of the South Island, and also Rakiura, the island right at the very tip of New Zealand. And looking in Fiordland was pretty hard. There's some really, real rugged, beautiful terrain there. And the kakapo there were found. There was 18 individuals, all of them male, just clinging on. In fact, one of the birds was found here on this cliff face, 1,000 meters up. For a flightless parrot, that's quite a long way above the valley floor. And that bird, this was called Richard Henry, he actually turned out to be very important. He lived for another 35 years. He's genetically very different and could be the crucial sort of key to the future of the population. Meanwhile, a bit further south on Stewart Island, a population was also found there, and it included females, which was crucial. But those birds were being eaten by cats at a very fast rate. And so in the 1980s, there was quite a bold and controversial move was made to move those kakapo from those places where they're being predated to these offshore island sanctuaries where there were no pests, no of these mammal species. And today we have kakapo on 5 of these island sanctuaries around New Zealand. On Whenua and Anchor Island are our 2 main breeding populations, also Te Kākahu, Pearl Island, and Hauturu in the north of New Zealand. So this is kind of where they are today. Well, what does the picture look like over the last 40 years or so in terms of the population? Well, it's a story of decline and recovery. The formal Kākāpō Recovery Programme was started in the mid-1990s when there were just 51 kakapo. And today there are 204. So the population is exactly quadrupled in that time. And there's actually been an increase of about 70% in the last 5 years or so. So how has that been done? What are the tools with which this conservation management works? Well, it's based around a bit of technology, transmitters. So every kakapo has a name, and every kakapo wears one of these transmitters. It helps us to find the kakapo, but it also helps us to track their activity. And we also do a lot of really intensive breeding management as well, because kakapo don't breed every year like most birds. They only breed about every 2 to 3 years. So when it happens, we have to optimize it and make it as productive as possible. And that breeding management starts with mating. When a kakapo mates, when a male mates, this is kind of what he looks like. The transmitter on his back detects that motion, switches on a receiver to detect who he's mating with. That transmitter then logs that information and transmits it to a series of data loggers, which we have around our kakapo islands. So they take that data, transmit it to the internet. So wherever we are in the world, we can tell which kakapo have mated the night before, who they've mated with, how long they've mated for, and even a quality score of their mating. So this is really key to sort of the first stage of that breeding management. Because then the kakapo nest, and a nest is a big deal. We want to make sure it's successful. So we put a lot of monitoring equipment in. We put an infrared camera, infrared sensor across the entrance, the proximity sensor so we can tell when the female is arriving and departing remotely. And we can even tell the activity of the female as well. So this is a graph of the activity for lots of different females. We can just tell if their incubation is being successful. We can even look at little things like this, where there's a dip in activity that was caused because a chick got sick. And we can tell that sort of thing just without even going to the nest. We also feed kakapo too during a breeding season, and that's really important to make sure they're in optimal breeding condition. And the way that we do it is with a series of these feeding stations. Every kakapo has its own feed station, and it's connected to a data logger. This is Lisa at her feeding station. She's moving in real time. I don't know what the video looks like you're in, but she's moving very slowly. Kakapo tend to do everything quite slowly. The data logger recognizes it's her from a transmitter, and so it opens the lock on the lid, so then she can get in to feed. She's also standing on some scales, so that weighs her and it logs her weight, so that we can then get that information remotely too. But kakapo are kind of, the males especially, are pretty greedy. They try and steal each other's food. So this is the same night, another bird comes along. This is a male, He's not the bird we want to feed at the station, so the data logger knows to lock him out. So the lid is locked. He tries to get in pretty hard. This is a thick steel stake in the ground, but he still can't get in, but he's pretty strong. He managed to get a few pellets out, but not enough for a good feed. And so what this does, it enables us basically to feed each kakapo individually, to put them all on their own diet. Well, why do we want to do that? Well, it all comes down to sex ratio, because initially we wanted a sex ratio of 1 male to 1 female, but in the early stages of the conservation, it was very male biased. There weren't enough females. And it was found that when the females were fed, if they got too heavy, they produced too many male chicks, which was producing this bias. So basically, the females were put on a diet. The feeding was optimized. We tried to keep them within the range between 1.5 and 1.9 kilograms. And then after that, the sex ratio becomes much nearer to parity. Not quite 1, but much closer. So this is an example of some of the methods that we use, trying to use the science behind it to try and manipulate and to try and promote the health of the population. But of course, there are issues. Kākāpō are critically endangered. There are 204 of them left. They are on the brink of extinction still. And there's some reasons for that. And probably number one is fertility. They have very low fertility. Only about 60% of the eggs are fertile. Of all of the eggs that have been hatched so far in the program, more than half have either been infertile or dead embryos. Less than a third of them turn into chicks that fledge. So we see lots of embryo deaths. That's at least partially a result of genetic inbreeding. We see poor sperm quality in males as well. That's also associated with inbreeding. So we should do artificial insemination to try and improve the fertility of Kākāpō clutches, and also to try and increase genetic representation, because Kākāpō don't breed every year, but there's some males who have been trying to mate for decades and have never been successful. So we want to make sure that these birds are represented in future in the gene pool. So we get a lot of help from around the world. We get external experts in, who are experts in artificial insemination. And it's been going on for quite a long time. Since 2005, we tried it and it was not successful. Then 2008 again. But in 2009, the team were the first in the world to be successful at artificial insemination in a wild bird species. But that doesn't guarantee future success, because the next 3 times we tried in breeding seasons, it didn't work again. Until last breeding season in 2019, we produced 3 chicks, one of which is surviving from artificial insemination. So this is quite an important tool that we'll continue to use in the future to try and maintain as much genetic diversity and improve fertility. There's other issues too, of course, and with threatened species, disease is always a problem, always a concern. And if you're eating at the moment, I'd suggest you just shut your eyes or look away if you're a bit squeamish, because I'm just going to show you a disease called crusty bum in Kākāpō. It's also called cloacitis. On the left of the screen is what a Kākāpō healthy cloaca should look like. The other ones is what happens when it has this disease. This can be fatal, and it's increasing. We've known about it now for about 17 years, but we're getting more and more cases. And we're trying to understand why. There's been a lot of research done, but we still don't know what causes it. Other diseases too. Last breeding season, we had a big outbreak of aspergillosis, which is a fungal pneumonia. It affects humans, but it also affects birds too. It affected the females and chicks, which were breeding on one of our islands. And we ended up having to send nearly 50 of them to the mainland for CT scans and for hospital treatment. And some of those birds were in hospital for 9 months. But it was a huge collaborative effort with lots of vets from around New Zealand and around the world. And out of 21 affected, only 9 died. I say only 9, that's still a lot of Kākāpō for us, but it was a much better outcome than it could have been. And we're now working with people around the world, especially some fungal geneticists, to try and understand where this fungus came from, this particular strain, how it fits in with the global patterns from human medicine and from environmental samples. So that's a couple of problems. Disease and infertility are real issues for Kākāpō. We have a new problem now too, which is kind of a nicer problem in that we're running out of room. We need more spaces to put Kākāpō, because with all of these chicks being produced, a 70% increase in the last 5 years, our islands are filling up. And I'll illustrate that now. So this is Whenua, with one of our main sites, and this is just some GPS data. The GPS trackers were not on all of the Kākāpō, only about 2/3 of them over a period of a couple of years. So this is not complete data set by any means, but hopefully it shows you that the island is nearing or at capacity. There's really not much space on here. And the spaces that you do see are actually probably got Kākāpō in them just without GPS trackers. So we want more sites. But the issue is that there are no ideal Kākāpō sites left in New Zealand. All the suitable habitat has too many predators in it. But we have managed to identify some sites. There's one called Mangatautri, which is a mainland island in the middle of the North Island of New Zealand. It's a large fenced mountain, about 3,000 hectares. And then there's a couple more in Fjorden, where we're hoping to translocate Kākāpō to all of these sites in the next 2 years. Resolution is particularly significant for us because it's the site where the first Kākāpō Ranger started. There was a guy called Richard Henry who in the 1890s moved to this island, lived almost alone there for almost all of the time, and single-handedly rowed hundreds and hundreds of Kākāpō to this island from the mainland where they were being eaten by stoats. He was a real pioneer in conservation and conservation translocations, not just within New Zealand, but in the world. And we're hoping to complete the circle. 130 years later, we want to put Kākāpō back on this island. But the way that we do Kākāpō conservation is changing, and it's quite an exciting time for us because Kākāpō conservation is famously or almost infamously intense. I could not believe when I started and joined the program just how intense it was, how much care and attention went into every chick, every egg, every nest. But we can't continue that. As the population grows, as we have more Kākāpō at more remote sites, we cannot continue to be so intensive. We have to be a little bit more hands-off. And one of the solutions is through the technology, and particularly through our remote monitoring systems. Because we have all these data loggers. We have feed station data loggers, we have mating data loggers, we have nest data loggers. And what we've done recently is put them all together and combined them all in this internet of Kākāpō things, this radio network which connects all of those devices together. They all transmit data through the network to a central site, which then goes to the internet. And this enables us to monitor Kākāpō much more closely, but remotely, without having so many people on the ground, without having to be so close to the birds all the time. We also use drones as well. We've been using drones to transport sperm from the male to the female when we're doing artificial insemination to make it more efficient. We're looking at using drones to track Kākāpō more efficiently as well from the air than it is on the ground. And there's little incremental things we do as well. And smart eggs, I guess, is a kind of an example, because when a Kākāpō nests, we normally take the real eggs away and we put them in an incubator because we tend to be a little bit more successful at incubating Kākāpō eggs than Kākāpō are. We replace them with a dummy, and we've made a realistic dummy because we've got a real Kākāpō egg, and we got Weta Workshops to make a 3D model. These are the people behind some of the special effects of Lord of the Rings. They made this model, and we now have 3D printed eggs, which are an exact replica of a real Kākāpō egg. But the problem with these dummies is that the chick will hatch in an incubator, and when the chick hatches, we put it back in the nest. But the mother tends not to feed it very well for the first few days. And so we end up having to feed it in the nest for her, which is really intensive and quite dangerous too. So we think the reason for that is because she doesn't know that a chick is on its way. She's been sitting on an inert egg. So what we've done now is we put little speakers inside these eggs and created this smart egg, put those inside the nest just before the chick hatches in the incubator. So the mother gets a cue. She knows that a chick is on its way. So when the chick goes back in the nest, she will then feed it properly. So that's kind of a bit of a whistle-stop tour of Kākāpō conservation in a nutshell. I've just given you a few of the highlights. There's obviously lots more that goes on behind the scenes. But I'd like you to just take away just a couple of points from this. Is one, there are a lot of threatened species in the world, obviously, but this shows that if you have the right approach, if you have the right resources, you can actually turn this around. If you have a dedicated program and you use a science-based approach, that will work. And that's not just Western science, of course, that's indigenous science too. And so Mātauranga Māori is something that we really try to incorporate into our program as much as we can. And we work really closely with local iwi. We want to restore the mauri, the life force of Kākāpō. At the moment, that is not restored. They're in these intensive care units on these islands. We want to restore them to the mainland of New Zealand, where they can form a natural part of the ecosystem, the life in New Zealand that they're used to. But to move to these larger scales, that's where I think we have to rely on technology. That's a real key part to enable us to manage more remotely on bigger scales with less intensity. And we don't want this just to be about Kākāpō too, of course. We know that we're lucky that we can divert these resources to these incredible birds, but we want these methods that we develop, the technology that we develop, to be able to extend to other programs, obviously not just in New Zealand, but around the world, so that we can really contribute to the bigger picture of conservation globally. So yeah, that's me. That's just a real quick tour. If you want to know more, you can check out our website. where we have quite a lot more information. You can do things like adopt a Kākāpō as well if you want to, and you can follow me on Twitter as well if you want to keep up with what's happening in sort of a bit more real time. So yeah, I just want to thank you all very much for listening, especially if you've been watching at some really unsocial hour, and a huge thanks to Joe and the team for inviting me to talk. And if there's time, I'd be keen to take some questions.
Oh yeah, absolutely. There's definitely time to take some questions. So those who are tuning in, the live Q&A app is there. Let's get some questions in, because it's just, I mean, the technology, like I knew it was an exciting project, but just to see the technology from, the smart eggs right down to the knowing who mated with who and how successful it was, I just, it's absolutely incredible. It must be, knowing how technology can not always cooperate. There must be some good days and some bad days.
Yeah, that's certainly true. I mean, I'm definitely keen on applying the technology. Applying the technology in the field is very different, and that's something a lot of people don't realize. You can't just have your nice gadget like you use at home. Being able to put it in a wet forest environment and have it there for years on end, and still work and not fill up with water, is quite a key thing. And our team, when we work with the Department of Conservation's electronics team, they have learned a lot about how to waterproof things effectively. So that's really key.
Very cool. Simon would like to know a little bit more about the smart eggs. Can you tell us a little bit more about how those work?
Yeah, so at the moment, a kind of smart egg they are smart, but they're not super smart. All they have at the moment is a speaker in them, which basically we've recorded chick sound. So just before an egg hatches, the chick inside makes little peeping noises, makes little chirping noises. So it basically plays those back on a random cycle. And we've just had 1 year of those. We're about to do them in the next breeding season, but it looks like they may be having an impact. And it's an incremental change, but it's something that we want to really develop, and we want to go further. We want to maybe make them move a little bit as well, so a little bit more realistic. And also they can log information. So temperature and humidity of nests is important. So ultimately we'd like to be able to incorporate those into these eggs too.
Yeah, of course. What is the average lifespan for,
Yeah, good question.
Of course, but yeah, what's kind of an average lifespan?
The true answer is we don't know, because we've never tracked a Kākāpō enough from sort of natural birth to death. But we estimate from transmitted wear it's an average of around about 60 years. But it will obviously, that's the average, so we'll obviously extend much higher than that. So probably up to 90, maybe 100 years. And we're doing some work on that at the moment. We've tried quite a few aging techniques. What methods that work for other animals don't work for Kākāpō. Kākāpō never follow the rules. So yeah, it's something we want to work on, but it's quite an important thing, because we've got some of our population, probably about a fifth of our population, who are unknown age. They're birds we found as adults, were found as adults in the 1980s. So we obviously want to know when we can expect those to die.
Sure. It seems like the smart eggs are a popular topic right now. And Kelly would like to know, so how many would be in an average clutch, and could a smart egg potentially be used to regulate temperature a little bit in the future?
Yeah, that's a really interesting thought. A clutch is normally 2 to 3. Overall, it's about 1 to 5. We've had clutches of 5 eggs. A Kākāpō normally on our islands will struggle to raise more than 1 chick. That's really quite unusual. So normally we end up having to take some chicks away and hand rear them, because if not, they'll just naturally starve in the nest. But the incubation is interesting. We find if a Kākāpō's got more than about 3 eggs, it probably can't incubate them very well. We tend to take them away because we're a little bit more successful. But yeah, that is definitely possible. You could look at if you could use the egg in some way. But to be honest, incubation temperature, they're pretty good at it. Like that wouldn't make that much of a difference. There's more the chick survival, which is an issue, rather than the egg survival.
Okay, I'm only asking one more smart egg question. If any more come in, I'm not putting them in. But Frank's tuning in. Frank's wondering if there's like an element of smell involved with the eggs, or is that not really a factor?
Yeah, no, that's a really good point. Kākāpō do have a really good sense of smell. And we're very lucky in that they're very accepting of us putting weird things in their nest, including these eggs. And in fact, one of the things that we do is we often foster chicks between nests. So we'll take one mother's chick, give it to another mother, and she accepts it fine. In fact, I've gone to a Kākāpō nest. She's been sitting on an egg. I've put a chick in. Later on, a couple of days later, I've gone in, taken that chick out and put an egg back in. You can do it while the mother is sitting on the nest. She accepts it. She must know all those things are not hers, because they've got such a good sense of smell. But we're very lucky that they're kind of incredibly protective, and they'll kind of incubate whatever you give them and feed it too.
Awesome. All right, moving away from smart eggs for a little bit. Julianne would like to know, So I imagine where they are right now, it's probably pretty predator free. So if it's not, is there anything being done? And then is there potential for programs to maybe try to remove predators from other areas, maybe other islands?
Yeah, that's critical. And that comes every conservation program in New Zealand comes back to this issue of the predators. We have a lot of predators here which are not meant to be here. The native wildlife has no defenses against them. And yes, there is actually this kind of crazy big scale goal to try and remove a lot of these predators from the whole of New Zealand by 2050. So that's things like rats and stoats and possums. That's incredibly ambitious, but that's actually happening on some sort of smaller scales, and it's building momentum. And there's a lot of local ground sort of grassroots work being done, but also research too. So that's key. And that we hope is the solution for Kākāpō. There's a lot of places we would put Kākāpō tomorrow. Perfect habitat, except there's too many stoats or there's too many cats. Get rid of those. And the Kākāpō problem is kind of solved, apart from these ongoing things of fertility and disease. But as the population grows, then they'll become less of an issue.
Yeah. And so, we saw the scale, and the transmitter could feed the right bird. So, obviously supplementing the diet. You showed that image, in the fjord up on the mountaintop. The bird clearly took some time to get up there. What are they feeding on at those altitudes?
Yeah, so Kākāpō herbivores, they basically any plant. They'll eat, and outside of a breeding season, they'll eat any type of plant. And there's some of those soils in those mountains, there's some fertile where the slips is actually really good. A whole huge variety of different plant types. It's then in the breeding season is when they switch to a different food, and they actually only breed in response to certain trees fruiting. And that's why they don't do it every year. They only do it every 2 or 3 years or so when these trees, and trees like the rimu tree, when they produce the fruit.
All right. So we'll steal one more quick question here. This might be from somebody who's following along maybe with the project. This is Sierra wondering, Sirocco. How is Sirocco doing? Is there a bird by that name?
Yeah, he's a pretty cool bird. He's actually partially imprinted on people. He got hand reared as a chick on his own, partially imprinted. He's actually New Zealand's official spokesbird for conservation. That's like decreed by the government. He's a real character. He's our kind of advocacy bird. So he lives in the wild. He's a naturally wild Kākāpō. Every few years, we'll put him on tour so people can actually get to see him. Because that's one of the issues that we have is people love Kākāpō, but they don't get to see them because they're kind of locked away on these offshore islands. So that's where Sirocco comes in. He's doing fine. He's living in Fiordland, and we're hoping to put him on tour again sometime soon, as soon as we can. But he's doing well.
Wow, excellent. I can just imagine what the tour is like. Maybe backstage passes for a little extra access. Sounds pretty cool.
Yeah, he's a character. He's cool.
All right, good stuff. Well, I do want to share this link again. I know you shared it, but I think it's worth sharing again. It's incredible work. I mean, the technology alone is amazing, and it looks like it's just going to get more kind of in depth, and bringing the drones in, and who knows what else in the future. So check out the work. There's a spot there to donate, so if you're excited by this work and this project and you want to help out, you can head there and donate directly. Of course, it's one of the groups that we're going to send a donation to after the festival. So please do donate to the general fund as well, so that we can send some money to some great conservation organizations all around the world. So Andrew, thank you so much. Huge shout out joining us from New Zealand. What a great project, and just what an amazing species. I could watch that slow motion camera approach over and over again. It's pretty cool.
Cool. Thanks, Joe. And thanks very much, everyone, for listening. Thank you.
All right. Thanks, Andrew.